Hello everyone. A very good evening. So let's wait for 5 to 10 minutes so that everyone can join this session. So yeah, hello everyone. I hope I'm audible and visible. So let's start the session. A very good evening everyone and warm welcome to all of you. My name is Pooja Verma. I'm the MRF Research Scholar from IIT Kharagpur. And instructor for this course is Professor Shamal Das Mandal, Advanced Technology Development Center, IIT Kharagpur. This is a week 12 live interactive session of signal processing techniques and its applications. So here we will go through some questions which is very similar to your assignment problem. So for this week, the content related to the power spectrum estimation. I hope all of you gone through the video lectures, and there is a for this week there is nothing much content are available. It is only two video lectures related to power spectrum estimation. So first we will solve some questions which is related to power spectrum estimation. After that, we will solve some questions, previous year questions which is related to all your uh, content related to signal processing. Okay. So first we will go through the some concepts related to power spectrum estimation. Then we will move to the questions. Okay. So first, what is a power spectrum estimation? So a power spectrum estimation it describes the energy distribution of a time series in a frequency domain. Okay, so it is a random signal which is in a time domain. We need to estimate in the frequency domain. So energy is a real valued quantity. So the power spectrum does not contain any phase information. Energy is a real valued quantity. So power spectrum only contains the magnitude information, not a phase information. Okay. So the power spectrum is estimated by simply computing the squared magnitude of the n point derivative of x of n and efficiently implemented by a fast Fourier transform algorithm. And the distribution of average power of a signal in the frequency domain is called power spectrum or power spectral density, power density spectrum. It is also called power density or power density spectrum. And already told you the power spectrum is calculated by fast Fourier transform or Fourier transform. Okay, so what is a power spectral density? Power spectral density is a real and a non-negative function of omega that represents the Fourier transform of the autocorrelation sequence of a wide sense stationary stochastic process. So the power spectral density is real and it is a non-negative function of a frequency. Okay, so the area under the graph of the PSD is proportional to the power of the stochastic process. So whatever area we have to calculate under the power spectral density is proportional to the power of stochastic process. So PSD is a measure of a signal power contributed by a frequencies with a within a band of width that with let's suppose d of center at the frequency k here. Okay, it is a real and a complex quantity expressed in terms of a squared signal unit per frequency units and can be plotted as a signal graph. So power spectral density is a real, it is a not a complex quantity and it is expressed in the squared magnitude unit. Okay, some information contained in the full discrete Fourier transform has been discarded from the PSD, power spectral density, and the variance of the original digitized record can be computed from the integral of the PSD. So what are the different properties of the power spectral density? There are some properties of a power spectral density which is useful for while solving a question. So if Sx of f is a real and even, then it is Sx of f is equal to Sx of minus f. already. I have told what is the even property of an even signal, that is x of t is equal to x of minus t. So power spectral density is also a even function. And the area under the the second property is the area under x of f is the average power of xt. So area under the power spectral density is the average power of xt only, that is minus infinite to integral of minus infinite to infinite s x of df is equal to r, that is autocorrelation at zeroth position, is equal to e x of t square. And the third property of the power spectral density is S x of f is the average power density, hence the average power of xt in the frequency band f1 and f2 is, it can be vary from minus f2 to f1 minus f1 s x of f df plus f1 to f integral of f1 to f2 s x of f df is equal to 2 into integral of f1 to f2 s x of f df. As we know that this is the one of the property of integration theorem. So Sx of f is a non-negative, and so that Sx of f must be, it is a non-negative function, so it must be greater than equal to 0 for all f. Okay, in general, any function S of f is the real even non-negative and has a finite area can be a PSD function or power spectral density function. So it is a, these are the some properties of the power spectral density. So the power spectral density is real, even and non-negative function of a frequency. Okay, and it is calculated by a finite area. And another point of discussion, topic is point of discussion is computation of energy density spectrum for deterministic. So the sequence x of n is the sampling version of a continuous time signal xa of t, where sampling rate is f of s. Then to obtain or to estimate the true spectrum of a finite duration sequence x of n, if energy is belongs to equal to integral of minus infinite to infinite mod of xa of t whole square dt must be less than infinite. Then the Fourier transform exists for this signal is x of s is equal to minus infinite to infinite integral of xa of t e minus j 2 pi f t dt. Okay, if there is any sequence x of n which is a sampling version of a continuous time signal sequence xa of t, then the energy is calculated by this, and their Fourier transform must be exist by this equation. And then Parseval's equality is calculated e of minus infinite integral of minus infinite to infinite mod xa of t square dt is equal to minus infinite to infinite mod of x of f whole square df. Okay, and the quantity x f mod of x f, this is a mod of, represents the distribution of the signal energy as a function of frequency and hence called energy density spectrum of a signal, that is S of f can be represented by S of f is equal to mod of x of f whole square. Okay, so the energy spectral density of any signal is represented by this S of f, and it is mod of square x of f. Now next is autocorrelation. What is it? Autocorrelation. So the autocorrelation function gives the measure similarity between the signal and its time delayed or shifted version of itself signal. Okay, so the autocorrelation function of a power or periodic signal of xt with any time period t is given by this expression, that is autocorrelation function is represented by r of tau, that is equal to limit t into infinite integral of minus t by 2 to t by 2 xt and multiplication of xt minus tau d tau, where tau is the time delay or delayed parameter. Okay, So autocorrelation is a major similarity between the signals but shifted version of itself, same signal. So estimating the spectral content or power spectrum of a random process based on a noisy measurement of the process that have finite data set. And if the autocorrelation function can be measured by two different methods. That first one is a non-parametric method, another one is a parametric method. Okay, but mostly we will be calculate by from there. Okay, now it is the some content related to this week. Now we will moving to the questions. This is the last week question. So first question is the power spectral density function is a real and even function. Option B is non-negative function. Option C is periodic, or option D is all of the mentioned. So power spectral density function is a already told you in the properties of the power spectral density. It is a real and even function, and it must be a non-negative function also. It can be a periodic signal. So correct option is option D, all of the mentioned. These are the properties of the power spectral density. Okay. The correct option is option D. A power signal is periodic signal and its function is real, even and non-negative function as per the definition and properties of the power spectral density. I hope all of you getting. So moving to the next question. Next question is energy spectral density defined. Option A, signal energy per unit area. Option B, signal energy as a function of frequency. Option C, signal power per unit area. And option D, signal power unit bandwidth. So how energy spectral density can be defined? So in the slides already described, the energy spectral density gives the signal energy equal to the area under the waveform energy spectral density versus the frequency curve. So signal energy as a function of frequency. It can be defined by the signal energy as a function of frequency. So correct option is B. Option B is the correct answer. Now moving to the next question. Next question is 4-point DFT of a real valued sequence are x of 0 is equal to 2, x of 1 is equal to 3 minus 4j, x of 2 is given as 1, x of 3 is equal to 1 plus 3j, and x of 4 is equal to 1. Then determine the energy density spectrum of a signal. So how we can define or how we can determine? It is not a 4, it is a 6-point DFT. So as we know that x of 0, x of 1, x of 2 and x of 3, x of 4 is given. Now we need to find out x of 5 and 6 also. Otherwise we can determine from this also. Okay, this is a 5-point DFT, not a 4. So as we know that already told you, the energy spectrum or the defined by the x of f mod of x of f whole square. Okay, so energy density function that is represented by let sx sf, or we can write it e, simple e. Energy spectral density e is represented by must be equal to sx of f mod square. Okay, so now we need to calculate summation of all these values, that is mod x of 0 square plus mod x of 1 square plus mod x of 2 square plus mod x of 3 square plus mod x of 4 square. So mod x of 0 is 2. So 2 is 2 square. Then plus x of 1 square. So it is a complex number. So first we need to find out the 3 square. How to find out the complex value, the magnitude? It is 3 square plus 4 square, that is 9 plus 16, 25, that is 5. Okay, so 5 square plus x of 2, it is only the real value, so 1 square plus x of 3 square. Similarly, we need to calculate this 1 square, root of 1 square plus 3 square. So root of 10. So root of 10 square plus x of 4 square, that is 1 square. So how much it is? 4 plus 25 plus 1 plus root of 10 whole square is 10 only, and plus 1. Now, yeah, correct question, 41. If you add all those things, it will come 41. Okay, so the correct option is option A, that is 41. Okay, so I hope all of you understand this question. So moving to the next question. So next question is, autocorrelation is a function which matches two same signals, or option B, two different signals, option C, one signal with its delayed version, option D is none of the mentioned. I hope you can answer this question. So please answer in the chat box so that we can interact or communicate. So what is the autocorrelation? Autocorrelation, yeah, correct. So autocorrelation is a integration of signal and a shifted version of that signal, already told in the x of t and multiplication of convolution of x t minus tau. T minus tau, that is represented by Rx of tau. It is a multiplication of signal and shifted version or delayed version of itself. So correct option is option C, one signal with its delayed version. Okay. Okay, so moving to the next question. According to the Parseval's theorem, the energy spectral density curve is equal to, option A is area under the magnitude of the signal, option B area under square of the magnitude of the signal, or option C is area under square root of the magnitude of the signal, and option D is none of the mentioned. Yeah. So what is it? According to the Parseval's theorem, what is the energy spectral density curve is equal to? So energy spectral density curve is equal to area under square of the magnitude of the signal. So already in previous slides you have seen that the magnitude is under square of that magnitude of the signal. That is a Parseval's theorem. Okay. So according to the Parseval's theorem, the energy spectral density function can be given as equal to the square of the magnitude of the signal. Okay. So correct option is option B. So moving to the next question. What is a Wiener-Khinchin theorem? Option A is spectral density and autocovariance makes a Fourier transform pair. Option B is spectral density and autocorrelation, that is a autocorrelation, makes a Fourier transform pair. Option C is a spectral density and variance make a Fourier transform pair. And option D is a none of the mentioned. So what is a Wiener-Khinchin theorem? The Wiener-Khinchin theorem, the power spectral density of a function is a Fourier transform of the autocorrelation function. And so that we can say that its power spectral density and autocorrelation makes a Fourier transform pair to each other. Example, this is a power spectral density of any signal and autocorrelation make a Fourier transform. Fourier transform. That is called a Wiener-Khinchin theorem. The correct option is option B. Power spectral density and autocorrelation, that is makes a Fourier transform pair, not a autocovariance or variance. It is a autocorrelation function makes a Fourier transform. So the correct option is option B. Okay. Okay. So moving to the next question. Autocorrelation function of a periodic signal is equal to option A is energy of the signal, option B is power of the signal, option C is its area in frequency domain, and or option D is none of the mentioned. So what is the autocorrelation function of a periodic signal? So autocorrelation of a periodic signal is calculated by the power of that signal. Okay, so option B is the correct answer. That power of that signal is calculated in order to determine the autocorrelation function of a periodic signal. We will see some the numerical question in further slides. Okay, so moving to the next question. Power spectrum describes distribution of under frequency domain, which under which option A is mean, option B is variance, option C is Gaussian, or option D is none of the mentioned. So the power spectrum gives the distribution of a variance of a signal in the frequency domain sampled into a spectral component. So it first sampled at the different spectral components and the distribution in the frequency domain gives the variance. So correct option is option B. Option B. The power spectrum describes distribution of a variance under frequency domain. Okay. Moving to the next question. Next question is how can power spectral density of a non-periodic signal can be calculated? Option A is by integrating, option B is by truncating, option C is by converting to periodic, option D is none of the mentioned. So how can power spectral density of a non-periodic signal be calculated? So what is a non-periodic signal? So non-periodic signal that does not repeat itself at a particular time. So let's see, this is a non-periodic signal, something like this. So how we can calculate the power spectral density of that non-periodic signal? So it can be calculated not by integration. By integration we can't calculate the power spectral density only. So first we need to truncate into a different part this signal. Then we need to calculate at every instant of time the spectral density of that signal. So correct option is option B, by truncating a non-periodic signal, we can calculate the power spectral density of that signal. The explanation is there given is a power signal usually a periodic signal, but power spectral density of a non-periodic signal can be calculated by truncating it and observing in the range of minus t by 2 to t by 2. So that range t value can be anything. Okay, so option B is the correct answer. Okay, so moving to the next question. So autocorrelation is maximum at which point? Option A is unity, option B is at origin, or option C is infinite point, or option D is none of the mentioned. So autocorrelation function is maximum at which point? So in the properties of the autocorrelation, we have seen that it is maximum at the origin. Any function, you can see that it is maximum at the origin. It is maximum at the origin. The correct option is option B. Autocorrelation is maximum at the origin only. Okay. Moving to the next question. These are the mostly theoretical questions related to this, but it is important because basic things we need to concentrate in this. So now, next question is the power spectral density of a random variable xt is given below for a positive frequency. It is given for a positive frequency. The variance of yt is equal to xt cos 2 pi f naught t, where f naught t is 5 kilohertz given. So power spectral density is given of any random variable xt. Now we have to calculate the variance of that xt. So how we can calculate? Already we know that the power spectral density and autocorrelation function makes a Fourier transform pair. So in order to determine the frequency component or a variance of a signal, we need to find out the autocorrelation of this signal yt. So how we can find out? R y of tau, it is represented by at a specific time period that vary from 0 to tau or 0 to t, x of t cos 2 pi f naught t, or it is related to tau, so we are converting, already told you, in the that is multiplication of t, multiplication of xt minus tau. Now shifted version of that signal x, it can be t plus tau or t minus tau. Here I am taking t plus tau. So cos 2 pi f naught cos 2 pi f naught t plus tau d t or d tau. Okay. So now in the compact form, it can be written as, it is a multiplication. If you cos 2 pi, if you do that all these calculations, you will get 1 by 2. This is xt, and xt plus tau multiplication can be represented in x r x of tau, and it is cos 2 pi f naught tau. Okay, so a cos we put it and then calculate, we will get this expression. Now we have to calculate the s y f. So how we can calculate? By s x f minus f naught plus s x f plus f naught divided by 2. Okay, here Sx of f given. So it is given at only the positive side. Then after in order to find out Sy of f, now we need to find out at the negative side also. So I'm not, we don't have a space, so I'm just putting here only. Now we will get in the negative side also minus 3 minus 2, and also it repeats at a certain point. At what is that point? What is the distance between two? That is 4. So after 4, that it will again repeat and repeat at a certain frequency. Okay, so now here it is, we have got Sy of f, that is Sy of f. Now in order to find out the variance of the Yt, how we can calculate? That is the variance of Yt. We can calculate from the output S Y F df. Okay, so here how much it is? 2 to 3, and again certain point of time it will again repeat. So if we can write it, then also if we it is divided by 2, so it will be the 4. The magnitude will be the 4. Okay, Sy of f, for Sy of f. It is 2. No, it is 4. It here we will get 2. So if we calculate area under this, we also 2 into 10 to the power 3. It is a 2 into 10 to the power 3 into 4. How after that how much period is? It will repeat. So total variance we will get 8000. Okay. So correct option is option C. Okay. I hope you understand this question. Can you answer it? One. If you understand, then we can move to the next question. I hope all of you have got this question. Okay. Thank you, Edwin. Okay. So moving to the next question. So the next question is, a random process is defined as x of t is equal to 6e to the power 80, where a is the random variable uniformly distributed in the interval 0 to 2. Then autocorrelation function Rx t1 into t2 is given as. Then autocorrelation function of this, how it is given as. Okay, so as we know that x of t is given as 6e to the power 80, right? And we need to find out the autocorrelation of this signal, that is represented by Rx t1 comma t2, and that can we find out mean or integration of Rx, that is, so we can write it in this form also, x t1 into x t2. Okay, now if we are putting the values of xt, then it is 6 e to the power a t1 multiplied by 6 e to the power a t2, right? If we calculate the expectation or mean of this, then 6636, and that is in the multiplication. So if we find out 1 by 2 integration mean of that this e to the power at1 and e to the power a2 that is distributed randomly distributed in the interval 0 to 2, then what we will get e to the power at1 in multiplication of e to the power a2 at2 can be written as a is common, then t1 plus t2 we can write it like this, and integration with respect to a. Okay, so what we will get 18, and now we have to integrate this part. So e a to the power t1 plus t2 integration with respect to a, so that t1 plus t2 will come in denominator also, and at which point it is integrated 0 to 2. Okay, so now 18 t1 plus t2, and if we will put with in the place of a is e to the power 2 t1 plus t2, and if we will put 0, then what we will get 1 e to the power 0 is 1. Okay, so which one is the correct answer? 18. The answer we got is 18 divided by t1 plus t2 in bracket e to the power 2 t1 plus t2 minus 1. So option A is the correct answer for this question. Okay, I hope you have understood this question. So note it down also. So moving to the next question. So the next question is related to the properties of the power spectral density. So if S of f is the power spectral density of a real wide-sense stationary random process, then which of the following is always true? Option A is S of 0 must be greater than or equal to S of f. Option B is S of f must be greater than or equal to 0. And option C or third is S of minus f is equal to minus S of f. And option D is minus infinite integration of a minus infinite to infinite S of f df is equal to 0. So in the properties part, we have seen that S of f must be greater than or equal to S of 0. So this one is wrong, and this one is also in the properties that is a even and non-negative function. So it is a property of odd function. So option 2 is the only correct answer in this. Yeah, option D is the correct answer for this question. Okay, so moving to the next question now. The next question is, if x of t is a signal, that is signal is applied to input to a LTI system with impulse response h of t. Okay, then the output of the system yt, then and value of yt at t is equal to 5 we need to determine. Then what is the value of yt at t is equal to 5 only? So xt is given, yt ht is also given, so we know that the convolution, in the convolution y of t must be equal to minus infinite to infinite x of tau h t minus tau, that is t minus tau d tau. From this formula we need to find out. Okay, so at, as we know that we need to find out at t is equal to 5, that is 5. So now what we need to do, that is varying minus 10 to 10, and it is a unit step function. Xt is given as a, it is nothing but unit step function. So now we are taking minus 10 to infinite. It is a positive side only. So x we can write in the other form also. Let's x, and it is h 5 minus tau h tau or d tau. We need to find out this value. So already we know that xt is a unit step function. Okay, then x t minus tau must, what will be the u t minus tau, sorry, 5 minus tau. This will be, then what we will get, u t minus tau in place of, that is like this, it is will start from 5, right? Now if we multiply with this, then what we will get, if we multiply both these equations, sorry, both the signals, it is from here, this side in the positive side from 5, and in the negative side it is minus of 10, and it is the magnitude at this one, it is 1, it is 5, then it is 5 only. Okay, so what we will get in this place, what is the area under this, how we will calculate, 5 into 10 plus, it varied 10 to 5, then tau into 15. So what will we get, 75. So at t is equal to 5, it is, answer is 75. Okay, then the output of the system at t is equal to 5 will be the 75 only. Okay, I hope you have understand this question. So moving to the next question. Okay, so the next question is, consider a random process yt defined as yt is equal to xt minus xt plus tau, where xt is a stationary non-periodic process and tau is a constant. If Rx of tau is the autocorrelation of a random process xt, then the variance of yt will be, then what will be the variance of yt? So here yt is given as x of t minus x t plus tau, and also it is given that xt is a stationary non-periodic process and tau is the constant, and Rx of tau is the autocorrelation of a xt. Then how we will find out the yt? So already we know that x square t, or expectation of x square t, is represented by Rx of 0 in the properties part, while they define the property autocorrelation function in the PhD. Okay, mean and variance part. Then the mean value of a random process yt, what will be the mean value the random process yt? Must be 0. Okay, and now we need to define, it is given, it is, we can assume that mean of yt is equal to 0. Then how we can find out the variance of yt? So variance of yt I am representing that, it is represented by y square t minus e y of t. It is a formula of finding out the variance. Okay, So it is given y of t, expectation y of t is equal to 0. Right now we need to find out the expectation of y square t. So y of t is given, that is xt minus xt plus tau whole square. It is given right, y square t, so this is whole square. Now if we ex expand this, then what we will get? I'm writing here expectation of x square t, right, plus a square plus b square minus 2ab. If we open this, expectation of x square t plus tau minus 2 expectation of xt into xt plus tau. Okay, and also we know that at expectation x square t or expectation x square t plus tau at the origin, it will be the maximum. So it can be represented by Rx of 0. After that I'm writing here, okay, Rx of 0, and that is also equal, so it can be also written as Rx of 0 cos and minus 2 Rx of tau, because it is the autocorrelation of two function x, the multiplication of xt and shifted version of itself. So it can be represented by this. So what will we get? R2 R x0 minus 2 R x of tau. Now if we take 2 common, then we will get Rx of 0 minus Rx of tau. Okay, so what we will get? We will got 2 in brackets Rx of 0 minus Rx of tau. Okay, so which option is correct? Option C is the correct answer for this question. Okay, okay. So I hope you understand this question. Okay, so moving to the next question. So the next question is, a zero mean random signal is uniformly distributed between limits minus a to plus a, and its mean square value is equal to its variance. Okay, mean square value is equal to its variance. Then the RMS value of the signal is, then what is, we need to find out the RMS value, root mean square value of that signal. Okay, so as it is given, a zero mean random signal is uniformly distributed. Okay, that means in the limits of minus a to a, and what will be the its magnitude? 1 upon 2a. Okay, so it is a uniformly distributed with the limit minus a to a signal. Now we need to find out the RMS value. So for finding out the RMS value, first we need to find out its variance. So how we can calculate the variance? That's where the variance is represented by sigma, so minus a to a x square, and that signal, let's, it is this, it is represented by p of x. So p of x dx. What is this? This is the x square. Okay, so the variance is represented by this formula. Now we need to put all those values in this. So minus a to a x square, and p of x having magnitude of 1 upon 2a, into dx. So 1 upon 2a. So it is integrated with respect to x. So what we will get? X cube divided by 3 is uniformly distributed minus a to a. So 1 upon here and 6a. What will we get? A cube minus of minus a cube. Then what will we get? 1 upon 6a. A cube plus a cube. So a cube plus 2a cube. So 2a cube divided by 6a. So a square by 3. What we got? It is a variance of that signal. Now we need to find out the mean square value of its. So what is it? So let's P. It is represented as PRNS. Mean square means that is root mean square. So root of a square divided by 3. So what we will get? A by root 3 if we further solve it. Okay. So what is the correct answer? Option A is the correct answer for this question. What we will get? A by root 3. Right? Okay. I hope you understand this. So can we move to the next question? Okay. Okay. So thank you. Okay. Moving to the next question. Then now the next question is consider the signal as given. The signal is given as x of t is equal to 10 sine 2 pi 100t, where t varies from 0 to 1 and 0 other places. Where t is in second, the energy of this signal is given. What is the energy of that signal? Okay, so signal is given as xt is equal to 10 sine 2 pi 100t. Right now we need to find out the energy of that signal. So the energy of this signal is represented by let E. The energy of signal is represented by E. And how we can calculate it is, it is given only for the range of 0 to 1 only. That is given 10 sine 2 pi 100t and 0 otherwise. So 10 sine, as you know that what is the formula for finding out energy of the signal? E is equal to minus infinite to infinite in a signal on x square t dt. Okay, so now we need to find out the 10 sine 2 pi 100t square dt, square of that signal, right? And we will from here, otherwise we will got confused. Now I'm writing here. Okay, so 0 to 1, 10 square is 100, 100 sine square 2 pi 100 t dt, right? Okay, so now also we know that sine square theta is equal to 1 by 2 1 minus cos 2 theta. We know that this formula because we can't directly differentiate this square function in the sinusoidal form. So first we need to put this into this. So 0 to 1, 100 divided by 2, 1 minus cos 2 into 2 pi. So 4 pi 100 t dt. Okay. Now it is 50. So it is 0 to 1, 50 minus 50 cos 4 pi 100 t in all in integration. Yeah. Now we need to integrate this. So it is 50, it is only so 50t and minus 50 cos 4 cos. When we integrate this cos, then it becomes sine 4 pi 100t, and that t will come 4 pi into 100t, right? And it is between 0 to 1. If we put 1, then it is 50 minus 1, then its value, then 4 400 pi. What will be the value of 400 pi? That will be the 0 only. Now minus, it will be 0 also, and minus of that sine 0 will be 0. So all value will be the 0 only. So energy of that signal is 50 only. Okay, if you solve and find out this. So correct answer is option 4. Okay, so option 4 is the correct answer. I hope you understand this question. Okay, so moving to the next question. Okay, so the next question is, a time domain energy signal is defined as xt with an energy signal equal to 50 joule. Then the energy of the signal 5xt in brackets 10t minus 10 is equal to. Then what is the energy of that signal? If the energy of the signal xt is given and let's energy is represented by 50. Sorry, energy is represented by E, then energy of the xt is 50 joule. Then what will be the energy of 5x 10t minus 10? Now, so as we know that any signal is xt having energy E, that, and it is given as 50 energy. Then what will be the energy of axt? If we calculate that, that is E square E, right? If we find out, and what is the energy of signal ax vt or plus minus E, that is E square E divided by V. I am not going into much details or solving this the equations. I am directly, you can find out in the properties of the energy signal. So I am taking it directly here. So here the signal is given how 5x 10t minus 10, right? Where A is 5 and B is 10 and C is minus 10. So if we directly calculate with this formula, what we will get? 5 square into E and divided by 10. and here E is given as 50 joule, right? So 25 into 50, here E is given 50 joule divided by 10, and what we will get? 125 joule. So energy of a signal 5x 10t minus 10 is 125 joule. Okay. Okay. So I hope you understand this question. So can we move forward for next question? Okay. Okay. So moving to the next question. So next question is the energy of a signal GT is 16 joule. So energy of that signal GT is given as a 16 joule. So find the energy of signal Ft. Now we need to find out the energy of that signal Ft. So already have discussed that energy of the signal Ft is E. Then what will be the energy of the signal A of Ft? That is A square E, right? And what will be the then energy of signal F of At? We know that E by A by the property of the energy signal in the first week video lectures. From there we can find out. Now the energy of the signal GT is given as a 16 joule. We need to find the energy of the signal. So energy of that signal is, and directly I'm just writing GT is equal to 4 F GT plus 9 plus 2 F T by 2 plus 6. Now if we apply all the properties of the energy signal, we will get here the energy of the GT is given 16 joule. Now in the previous also A square E by B. So 4 square and energy of Ft is represented by E divided by B, that is 4 plus that is 2, that means 2 square E, here the B is given 1 by 2, so 1 by 2. Now 16 joule is equal to 4 and 4 we cancel out, so here we will got 4E and 1 by 2 is going to 80 if we calculate it. So 60 joule is equal to 12E. So E is equal to what we will get 16 by 12E. If we further solve joule, that is. If we further solve it, what we will get 4 by 3, and if we again solve it 1.33 joule. Okay, so the energy of that signal Ft is 1.33 joule. Okay, this is the answer. Okay, so I hope you understand this. So can we move to the next question? Okay, so moving to the next question. So the next question is a signal f of t has energy E, and then what will be the energy of the signal f of 2t? So already we have discussed the signal, let's have energy E, then what will be the energy of f of 2t? That is E by 2 from the property, right? So the energy of signal f of 2t is E by 2. So the correct option is option 2. Okay. So I hope you understand this. Can we move to the further? Okay. So moving to the next question. So the signal energy of a continuous time signal is given as, that is xt is equal to, in bracket, t minus 1 u t minus 1 minus, in brackets, t minus 2 multiplication by u t minus 2, then minus t minus 3 u t minus 3 plus t minus 4 u t minus 4 is. Then we need to find out the energy of that signal. Then how we can find out? So already we know that energy of any signal is represented by minus infinite to infinite x square t dt, right? And xt is given as, in brackets, t minus 1 u t minus 1 minus t minus 2 u t minus 2 minus, in bracket, all those things are in bracket, t minus 3 u t minus 3 closed plus t minus 4 u t minus 4. Okay. How we can write it also, as we know that RT is equal to TUT, right? And RT minus 1 then equal to T minus 1 U T minus 1, right? We can represent it like this. And how RT minus 2 can be represented? T minus 2 U T minus 2, right? Similarly, we need to represent. Now xt can be written as, I'm removing it from here, we can write it. So now xt can be written as rt minus 1 minus rt minus 2 minus rt minus 3 plus rt minus 4, right? It can be written as, if we plot this xt, so how, what we got, what we can get, how it is plotted, something like this, right? At 1, 2, 3, 4, if we plot the signal, we will get this at magnitude 1. Okay. Now we need to find out, after solving till now, we need to find out the energy of that signal. So I'm removing it from here and writing it. So already we know that energy of that cylinder. Then now from plot we can see that the what will be the area and how we can get at repeat 1 to 2. What is the value? That is t minus 1, right? T minus 1 square dt, that is x square t, plus between the area under 2 to 3. What is the value is constant, that is 1. So 1 square dt. Now plus 3 to 4. What is the value of, that is the declining, so minus t at till 4 square dt, right? Now expand this. So what we will get, t square plus 1 minus 2t dt, and that will be the same. Then 2 to 3 1 dt, and now we need to expand this one also. And what we will get, t square plus 16 minus 8t, right? And dt. Now integrate all those values, then what we will get, t cube divided by 3 plus t minus 2t square by 2, that can vary 1 to 2. Okay, now plus here 1 square dt, so t 2 to 3 plus integrate this part, so what we will get, t cube divided by 3 plus 16t minus 8t square by 2, relation from 3 to 4. Now after that I am removing from here. I hope you all of you have noted down. So can I remove this part? And also we now we don't require this one for writing purpose here. We have to plot this and removing it also. Okay. So now we need to calculate. Then what we will get? Now putting all these values, then we will get 8 by 3 minus 1 by 3, that is if we are putting at t is equal to 2 and t is equal to 1. So this one plus 2 minus 1, putting the values of t, that 2 and 1, and it is 2 and 2 will be cancelled out. So 4 minus 1 t square, that is 2 square minus 1 square, that is 4 minus 1. And similarly here it is only t, so 3 minus 2 only. Now putting in this, so t cube, that is 4 cube divided by 3. So 4 cube is 64 divided by 3, minus 3 cube, that is 27 divided by 3, plus 16t, that is 16. 4 minus 3, putting the t is 4 and then 3 and multiplying it. Now, sorry, minus, it is minus 8, so 4 only. So 4 t square, that is 16, 4 square minus 3 square. So 16 minus 9, right? Now what we will get? Here we will get 7 by 3 plus 1 minus 3. Now here 3 minus 2 is 1 plus what we will get here? 64 minus 27, the denominator is equal, so normally we can, so here we will get 37 by 3 if you minus 64 minus 27. Here 16 only, 4 minus 3 is 1, so 16. Now 4, 16 minus 9 is 7, so it is 28. 4 into 7, 28. Now if we calculate all those things, then here we will get 44 divided by 3 minus 13, right? If we take that 37 plus 7, 44 divided by 3 and minus all those things. Now what we will get? 44 minus 39 divided by 3. Now what we will get? 5 by 3. 44 minus 39 is 5. 5 by 3. The final answer is 5 by 3 we will get. Okay, so which option is correct for this question? Option 4 is the correct answer for this question, that is 5 by 3. Okay, I hope you got this question. So can we move to the next question? Okay, so moving to the next question. So the next question is, what is the power of the signal xt, that is xt is equal to 8 sine 2 pi t plus 4 sine 4 pi t. So what will be the power of the signal? So as we know that the power of the sinusoidal signal is determined by the p is equal to ac square by 2, right? And here the two sinusoidal signals are added, so power is also additive in nature. So P1 plus P2, right? So let's, total power is represented by P. So P1 plus P2. First we need to find out the power of this signal and this signal. So what we will get? P1, that is AC square by 2. So AC is this 8, the magnitude of that signal. So 8 square divided by 2. That means 64 divided by 2. That we will get 32, right? And what we will get? P2. P2 is also AC square divided by 2. That means 4 square divided by 2. That means 16 divided by 2. That we will get 8. And the total power, what we will get? P1 plus P2. That means 32 plus 8, that is equal to 40. Right? So correct option is option 1, that is 40. Okay. Okay. So I hope you got this question. So moving to the next question. So next question is, for a signal y of n is equal to e to the power j pi by 2 and plus pi by 2. Which one of the following is true? Option A is power of the signal is infinite. Option B is power of the signal is 0. Option 3 is power of the signal is equal to 1, or option D is energy of the signal is 0. So for this signal, which of the following statement is true? So signal is given as y of n is equal to e j to the power pi by 2n plus pi by 2. Okay. So now we need to find out some values. So if the signal is periodic, then power of the signal can we find out is 1 by n. I is equal to 0 to n minus 1 or some value mod x of n. If it is a discrete time signal, this is a discrete time signal, right? And if signal is aperiodic, then power we can find out if signal is periodic. Periodic. Okay. And if signal is not periodic, then how we can find out the power of the signal? Not periodic or aperiodic. Then power of the signal we can find out 1 by 2n plus 1 summation minus n to n or 0 to n minus 1 mod x of n square, right? So first we need to see whether this signal is periodic or aperiodic. So how we can find out the periodicity of that signal? We know that in order to find out the periodicity of the signal, 2 pi n, that's 1 is pi, by that omega. So what is omega? Pi by 2. So 2 pi divided by pi by 2. So that is 4. So that means the signal is periodic only. So now we need to find out the power of that signal. That is, the signal is periodic. Then find out this formula first. We need to find out mod of that value, mod of yn. So e to the power j pi by 2n plus pi by 2. What is it? Will be the value of that? E to the power something square. Always you will get mod value of e to the power something 1. Okay. So now if we put this value in this, then what we will get? 1 by n, that is varies from 0 to n minus 1. 1 square, that is mod of, so mod of n. So what we will get? That is n times, the summation will be 1 n times, so n by n. What we will get? N by n. Where I can write it here. After that I am writing here. So n by n. Okay, this is written by n times n. So we will get 1. The power of the signal is equal to 1. So power we will get is equal to 1. Right? So correct option is option 3. The power of the signal is equal to 1. Okay. Option 3 is the correct answer. Power of the signal is equal to 1. Okay. I hope you understand this. So moving to the next question. So the next question is, determine average power of the signal xt cos 2 pi f naught t, where f naught is the fundamental frequency and t indicates continuous time domain. Okay. Okay. So xt is given as cos 2 pi f naught t, or we can write it 2 pi f naught t as omega t also, right? Omega naught t. We can write it like this. So what will be the average power of that signal? We know that one by t divided by 0 to t x square t dt. Now put the value of x 1 by t 0 to t, that is cos square omega naught t dt, right? And already we know that what is the cos square theta value 0 to t. If we do that, it is 1 by 2 1 plus cos 2 omega naught t dt, right? So 1 by t, if we further solve this, 0 to t 1 by 2 plus 1 by 2 cos 2 omega naught t in brackets dt. Now if we integrate this, so what we will get? 1 by t in bracket 1 by 2t minus that means cos, integration of cos is minus sine theta. So 1 by 4 that will go down, and sine 2 omega naught t, that is varies from 0 to t, right? Now if we further put the values of t, then what we will get? After that I am writing right. So 1 by t in brackets 1 t by 2, and directly putting here t by 2, and 1 by 4 omega naught t sine 2 omega naught t. Let's, this will discard because it is t is not defined. So what we will get? I'm writing here 1 by t in brackets 2 by 2 t by 2 only. If we remove this part, discard this part, first t is not given, so 1 by 2 only. So the power of that signal will be the 0.5 watt. Okay, so correct option is option 4. Option 4 is the correct answer for this question, 0.5 watt. Okay. Okay, so I hope you understand this. So can we move next question? Okay, so the next question is, consider a discrete time signal x1 of n is equal to a to the power n un. Identify which of the following is the correct statement. That is, it is a low frequency signal from -1, a varies -1 to a 0. Option 2 is it is a high frequency signal for a varies 0 to 1, and for a is equal to 0 it will represent band pass signal. And option 4 is frequency domain representation does not exist for mod of a must greater than equal greater than 1. So what is the correct statement for this, where x of 1n, x of 1n is given a to the power n u of n. So first we need to find out the Z transform of that signal. So what is the Z transform of that signal? That is, we know that 1 upon 1 minus a Z inverse. If we find out the Z transform a to the power n, we will get this. If we further solve it, we can get it Z minus a, right? And also we know that is -1 to 1, that is 0, 90 for digital filters, 180 degree, 270 degree. This area belongs to high frequency and this is the low frequency area. Okay, so from here And also, what is the ROC? Mod of Z must be greater than equal to mod of A. So if it is a low frequency, from minus A values minus 1 to 0, but this area is belongs to the high frequency, that means this statement is correct. And similarly, this statement is also correct because 0 to A varies from 0 to 1 belongs to a low frequency region, but here it is given high frequency. And for A is equal to 0, that means it represent the band pass signal. No, it is not a represented a band pass signal. So band pass signal is represent Z minus A, Z plus A. You know that. So frequency domain representation does not exist for mod A is greater than 1. Okay, so from minus A to A it is not represented. The correct option is option 4. The frequency domain representation does not exist for mod of A is greater than 1, right? Okay. So moving to the next question. I hope you have understand this question. Okay. So moving to the next question. If a signal x of t does not have any definite value at a certain point for a certain value of t, but has a definite value at a remaining point, then the signal is said to be a option 1 is non-periodic signal, option 2 is piecewise continuous signal, option 3 is deterministic signal, or option 4 is random signal. It is given that if a signal xt does not have any definite value, that does not have any definite value at a certain point, but for a certain value t has it has a definite value at a remaining point, then that signal is said to be what that signal is said. As we know that the non-periodic signal, what is a non-periodic signal? Then a non-periodic signal is any signal that does not repeat itself. That means it can be any signal. It does not repeat itself. The periodic signal is repeat itself at a certain time interval. Okay. So it is not this option is not a correct. Now also we know that what is a deterministic signal. So a deterministic signal is a signal that has a no uncertainty with respect to its value at any instant of time. It does not have a certain value, but it is defined at certain point, and at certain point it is not defined. So it is a piecewise continuous time signal, it will be said. Okay. So a signal xt does not have any definite value at certain point for a certain value of t, but has a definite value at a remaining point, then signal is said to be a piecewise continuous signal. That means it is represented by a, like it is defined a certain value, then at certain point it is not defined, like this it is not defined, all this. So this signal is called piecewise continuous signal. Okay. And also know that what is a random signal. Random signal is a stochastic signal characterized, or it is like a periodicity. Okay. So moving to the next question. For a periodic signal, Vt is equal to 30 sine 100t plus 10 cos 300t plus 6 sine 500t plus pi by 4, the fundamental frequency in radians per second. Now we need to find out the fundamental frequency of this signal. So signal is 30 sine 100t plus 10 cos 300t, this is the cos, plus 6 sine 500t plus pi by 4. Okay. Now we need to find out the fundamental frequency in radians per second. Now first we need to find out the what is the frequency of every signal. First we need to find out the omega 1. So what is the omega 1 here? Signal is represented by sine omega t. So what is the omega? It is 100. And what is the value of omega 2? That is 300. And the value of omega 3, I am taking omega 1, omega 2 and omega 3 is 500, right? So how we will find out the fundamental frequency? We can find out the fundamental frequency from here by taking the HCF of the frequency is HCF. It is HCF of omega 1, omega 2 or omega 3 in order to find out the fundamental frequency. We need to find out in radians per second. That's why I am not finding out the value of F naught. Okay. So HCF of 100, 300, 500. So what will be the HCF? Is 100, 100 is common. So HCF is 100. So that means fundamental frequency is 100 radians per second. So option 1 is the correct answer for this question. Okay. So moving to the next question. The result of the convolution x of minus t, convolution of del minus t minus t naught. What is the result of this convolution? X of minus t, convolution of del minus t minus t naught. So as we know that the impulse, it is the impulse response signal. If it is convolved to any signal, then we will get x minus t minus of t naught, the accepted version that we know. Okay. So what will be the correct answer for this question? Is option 4 is the correct answer. That is x minus t minus of t naught. If we convolve any impulse function to a signal, then we will get that signal with accepted version of that impulse. Okay. Okay. I hope you understand this. These are the basic problems. So, okay. Moving to the next question. Okay. So the next question is the condition of periodicity of a continuous time signal is. What is a periodicity condition for a continuous time signal? Option 1 is xt is equal to xt plus t naught. Option 2 is xt is equal to 1 by xt minus of t naught. Or option 3 is xt is equal to x square t minus of t naught. Or option 4 is xt is equal to 1 by xt plus t naught. So as we know that a continuous time signal xt is said to be periodic if it repeats itself after some time at some period, that is x t plus t naught. If it repeats at a certain time period t naught, then the signal is called periodicity, and this is the condition of the periodicity. So option 1 is the correct answer for this question. Okay, this is a condition of the periodicity of any signal. Okay, so moving to the next question. Next question is, which of the following is not one of the representations of the discrete time signal? Option 1 is sequence representation, option 2 is graphical representation, Option 3 is analytical representation. Option 4 is tabular representation. The question is given, which of the following is not one of the representation is a discrete time signal. So as we know that the discrete time signal is represented in the sequence form, that is any signal is represented in this form, that means 1 5 3 1 something. So this is a sequential representation of the discrete time signal. That's thus this is represented n is equal to 0. So it is -1 -2 this side and 1 2 3 this side. Okay, and the graphical representation is also possible for a discrete time signal. We know that at least n is equal to 0 it is 5, at n is equal to 1 it is 3, and n is equal to 2 it is 1, and at 1 is n is equal to -1 it is 1. So graphical representation of discrete time signal is also possible, that means it is correct. Also analytical representation, that is not possible in the discrete time sequence. So option third is the correct answer. And tabular representation is also possible. We know that we can represent in this form, at like this one is table, the values of n, and there it is a x of n. So that we can -1 0 1 2 3, that means 1 5 3 1 2. So this is the tabular representation of a discrete time signal. The tabular representation is also possible for a discrete time signal representation. So correct answer is the third one. Analytical representation is not possible for a discrete time signal. Okay. Okay. So I hope you understand these questions. So for this session, these are the some questions. So now if you have any doubt, you can ask. Otherwise, you can close the session. Okay. So I'm waiting. If you have any doubt, you can ask. Otherwise, you can close the session. I hope all of you understand these questions. These are the some important questions. How many questions will be asked for the end exam? That I don't know. I think that that have been told in the that session. When sir is taking, and that mark distribution, and for their mid exams evaluation and assignment questions related to assignment. I hope 10 to 15 questions they will ask for in the, I think, for that exam. Exactly, I don't know. Okay, yeah, thank you, Asim, thank you. So now, if you don't have any questions, so we can close this session. So thank you for everyone for joining. I hope it would be helpful for you. These questions. Okay. So all the best for your exam to all of you. Now we can close this session.